This will significantly lower the power consumption of the entire millimeter wave PLLs. In the conventional LFD, we utilize the direct mixing, where for 1/6 operation, the injected signal mixed with fifth harmonic, which has very small output amplitude, resulting to narrow rock range. In this work, we propose to use dual-step mixing, where injected signal mixed with fourth and further fundamental, and be able to lock the injected signal. It results to the widest lock range reported for the 1/6 operation of 30.4%, with the highest volume of 3.7. So, if you're interested, please come and visit at TU21.
My name is Hwang Min-Tian from the University of Electrocommunication, Tokyo, Japan. Today I will present an ultra power LNA design using SLTB CMOS devices. This is the first LNA design using SLTB. This is a silicon on thin burned oxide CMOS technology. SLTB CMOS devices has a lot of advantages, such as high transconductance, low liquid current, low threshold voltage, and small parasitic capacitance. The LNA is optimized at 920 MHz, no cascade transistor, and the bucket of the driver transistor is applying a positive voltage to increase performance. Performance of the circuit is shown in this figure.
I'm Abdul from Egypt, University. The design is the researcher of this research low insertion loss and small bandwidth compactness and high selectivity. The design here uses both the pattern ground shield and split ring resonator, and by using these techniques, we enhance the insertion loss and also enhance the return loss of the filter. The simulation and measured results are shown. We got better insertion loss from the exam with 2.5 decibel, and the center frequency was 52, and the bandwidth was 13 gigahertz. Thank you.
My name is Keigo Enomoto from Hiroshima University. Differential circuits are widely used to compensate the low gains at millimeter wave. So balance are important circuit. This figure shows standard structure of transformer balance. Our problem when designing balance mismatches of between outputs. Accordingly, we improved CMRR at 80 GHz by adjusting the position of port and center tap. In addition to this, we considered diameter of the balance and the impedance of the port. In short, we optimized in the fourth dimension. I present detail as a poster, so please come to me. Thank you.
It's missing. Okay. Sure.
This figure shows the mixer configurations. We analyze the output power of these diode mixers. Our objective of the study is formation of the third-order intermodulation of these diode mixers. This figure shows analyzed and measured IMC of diode mixers. They are in good agreement. These equations are the formulated OIP3. These equations are in good agreement with experimental investigations.
My name is Honeycomb, Canada Institute of Technology. This figure shows the proposed even harmonic mixer with pulse scale low. The conventional even harmonic mixer has disadvantages. Our objective of the study is to improve the the output power and the distortion. For the analysis of the output power, characteristics of the proposed harmonic mixer in modulator operation are formulated. So, with the substitution of one tone or two tones input signals into this equation, the output power and IM3 can be calculated with this.
Today, I would like to talk about high-efficiency rectifier circuit. The proposed rectifier circuit employs a double voltage type rectifier circuit. The input matching circuit consists of a series transmission line and open stub in parallel and capacitor. The output circuit employs a parallel capacitor and a series inductor. The five-kit rectifier circuit achieves RFDC conversion efficiency 87.5% at 10 dBm input per 1.8 GHz. Come to TU28. Thank you for your attention.
This work is present design of inductive coil for rechargeable battery that made for implant medical application. We use flat spiral coil to design an inductive coil wireless transmission and use lossy matching network to be adjust coupling factor between the source and the internal resonance load. The topology of inductive coupling is shown in figure 1. Inductive coil are transmit power by using resonance frequency from transmit coil to receiver coil. For result, we need power input 20 watt and excitation by 28 kHz of signal to measure percent of efficiency that change according to distance and performance of power transmission are illustrated in figure 2.
Okay, so we're interested in the realizing the millimeter wave multi-user mining system, and my post is particularly about how to suppress the intercarrier interference in the OFDM system, and our proposed method was able to mitigate the ICI by introducing the periodic structure for the phase noise, and this can be implemented by upconverting the signals at the simultaneously by splitting the OFDM symbols, and so and our simulation results shows that that it was successful to reduce the ICI in a several dB, and so we demonstrated our proposed method was fine. So for more details, please visit my posters, and I'd like to explain in detail. Thank you very much.
My name is Takayuki Matsumuro of Kyoto University. The objective of our research is small-size, high-gain antenna for efficient microwave power transmission. For efficient power transmission, the directivity of antenna is important. It's well known sharp directivity can be obtained by synthesizing spherical wave. But the radiation Q of the multipole is infinitely large. Large radiation Q degrades the radiation efficiency like conventional super directive antenna. So we proposed a new method of synthesizing spherical wave. That is a replacement of multipole to dielectric resonators. By this method, the radiation Q is much improved. Thank you very much.
In this presentation, I'd like to talk to you about SIW phase shifter with multipole. We call Honeycomb SIW. Using the proposed Honeycomb structure, we can freely control the dielectric constant of it in the SIW. We designed some Honeycomb SIW phase shifter utilizing the H-plane plan non-circuit approach. This figure shows a design example of 30-degree phase shifter. Because it is very compact, we think that it's expectable to improve the characteristic of microwave and millimeter wave circuit. Thank you for your attention, and I'm looking forward to meeting and talking with you.
Good afternoon, ladies and gentlemen. My name is Paibun Yoyot. Today I would like to present my work, Impact to the Measurement Density of Dielectric Permeability from its parameter measurement density in the transmission reflection method. This research about the uncertainty estimation of dielectric permeability of material from the uncertainty of its parameter measurement by Monte Carlo method. Considers block diagram. The S parameter data and uncertainty in normal distribution is generated. The relative permittivity and uncertainty are estimated from this equation by Monte Carlo method. For example, calculations by Monte Carlo method with 10,000 trial visualized sample has the relative permittivity uncertainty is in the range of 0 to 0.9 when its parameter uncertainty is in the range of 0.003 to 0. Thank you very much.
We have developed a new uncertainty analysis algorithm for permittivity evaluations of high-loss materials. In the transmission reflection method, a sample is encapsulated in a waveguide or coaxial line. The permittivity of a sample can be derived from measured S parameters by this equation, where beta is a weighting factor specified by the ratio of S parameter uncertainties in the conventional method. We have optimized beta in order to minimize the uncertainty of permitted measurements resulting from those of S parameters. We have confirmed that the optimization process provides a reduction of the permittivity uncertainty as less as 1/4 of that by the conventional method for the most significant case. Thank you for your attention.
I'm Masahiro Horube from AST. I'm not young researchers. So the primary speaker, Dr. Yamazaki, not come here due to personal reason. But we like to explain our research. So our research target is electromagnetic shielding guards used for the MRI rooms, and this glass require the high rest shielding effect and optical transparency. So the detailed information I can explain in front of you. Thank you.
I'd like to talk about electrically switchable reflector implemented on the electric circuits. Switchable reflector can be switched radar absorber and metal reflector. This is our structure of our proposed reflector. It has a pin diode on the surface, and pin diode perform resistance and capacitance without DC bias, and resistance and inductance with DC bias. This graph shows the reflection coefficient of our proposed reflector. As a result, switchable reflector can switch reflection level and be switched offset, be switched radar absorber and metal reflector. Thank you.
This is a proposed subsystem tuner sheet, where n is variable number of conducting line between character diodes. The right figure is analysis result with various and matching condition is also indicated. Analysis results that show that variance and
results heritage of the SIG shifted by the change of the result. Sorry, it is clarified that the proposed seed has potential for application to tunable web app solver. Thank you for listening.
My name is Kanchani Pindesong. This paper presents dual band multiple use slotted microstrip antenna and a design of multiple use frequency selective surface or FSF. It is scaled with its similar periodicity for bandwidth enhancement, which are regulated by wireless LAN and WiMAX application. The maximum gain are 9.3 and 7.3 dB at resonance frequency 2.45 and 3.5 GHz. Thank you very much.
My name is Jolip Peta. The simulation result is shown in figure 1 is F11 of tag on EVG and a band of stop exit at about 972 MHz. The pattern of the tag antenna on EVG in the H plane and E plane can be seen from figure 2. The tag had the gain of 6.3 dBi at the frequency band of 972 MHz. In this paper, prototype is 8 cell multiplied 6 cell. The design of a dipole antenna with electromagnetic band gap for RFID tag is presented in this paper. This tag can be well used on metallic objects. It is low cost and higher gain. Thank you very much.
My name is Salam Kampipat. My research work is gain improvement for the rectangular horn antenna with addition EVG. This design, this paper presents the quality. This presents the quality shape of multi electromagnetic band gap or EVG to improve the gain of rectangular horn antenna. The design parameter of the gain improvements on R and D. At R equal to 5.1 lambda and D equal to 31 lambda can provide the high gain of 26.31 dB, increase about 8 dB approximately, and the radiation pattern in both planes are quite symmetric at the difference. Thank you.
Good afternoon, my name is Nishna Kapian from SUT. The objective of this study is compare the result between upturn and overturn curved strip dipole, which is the exciting phase of circularly polarized resonator antenna. Exciting phase is overturn and upturn curved strip dipole. The component consists of curved strip dipole antenna, substrate layer, and PEC reflector plane. Frequency is 1.92 to 2.18 GHz. Maximum gain is 20.11 dB. It can be improved to mobile base station antenna. Thank you very much.
I'm Adi Barakat from Egypt. This paper presents case gears antenna on chip using a symmetric artificial conductor on CMOS, and here we build a symmetric artificial conductor instead of normal artificial conductor. This because symmetric artificial magnetic conductor can enhance the insertion loss for the microstrip line. Then the total gain of the antenna will be enhanced. As we see in the first figure, we can have 2 dB enhancement between for the insertion loss when using with a symmetric artificial conductor, and so the gain is enhanced by 1.74 decibel when comparing to the original artificial conductor. Also, the strip size is reduced as shown in the figure if you compare. Thank you.
everybody. My name is Lansini Sukhama from KMUTNB. Today, I would like to present bandwidth enhancement of collinear antenna from UHF band. The collinear coaxial antenna is presented for wideband jammer application. Can show in figure 1. The operating frequency is requested cover GSM 800 and GSM 900 along the frequency length for 824 MHz and to 960 MHz. The antenna is made by using highly coaxial cable with the diameter of 2.22 cm, where the velocity factor of a transmission line is 0.88. Thank you.
Good afternoon. My name is Radiating from KMUTNB, Thailand. I would like to present an omnidirectional antenna using singular ring regulate horizontal polarization for the TV reception. The proposed antenna consists of singular ring that is designed on bed sheets as shown in figure 1. The operating frequency range from 470 to 862 MHz as the TV frequency as shown figure 2. And the antenna radiates omnidirectional pattern with horizontal polarization as shown in figure 3. The mature results show that the proposed antenna can be a good candidate for the TV reception. Thank you.
Good afternoon, everybody. My name is Kane Ukapan from KMUTNB. A dual-band bidirectional rectangular link antenna fit by CDM with HF sleeve for Wi-Fi application. A dual-band bidirectional rectangular excited by CDM proposed. The parameter study has been carried out for the WLAN application. It's obvious that the antenna radiates bidirectional beam with the measured beam 82 degrees and 73 degrees for 2.45 GHz. Thank you very much.
My name is Pariya Janapat. I would like to present a circular polarized unidirectional antenna using protected for USF reader. The USF reader antenna radiating circular polarization had been characterized. The measured results show the impedance bandwidth of 9.1% and the 3 dB axial ratio of 6.3%. The measured front to back ratio is 27.5 dB and gain is 9.8 dBIC at center frequency. It can be operated along the frequency range of 920 to 925 MHz with easy design. Thank you so much.
Afternoon, everybody. My name is Vishnu Sombatkhan from KMUTNB. Today, I would like to present the improvement of spiral rectangular shape antenna for short-range RFID communication. In figure 1 show fabricated antenna and 2D magnetic field. The operating frequency range from 840 MHz to 960 MHz at UHF frequency. The communication area is 15.4 cm multiplied 15.4 cm at the frequency band between 840 MHz to 960 MHz shown in figure 2. The often 95% leading rate is achieved at a distance of 0.5 cm shown in figure 3. Thank you.
My name is Palayarum Jampa. I am from SUT. In this paper, we have compared the performance of multi-led wireless LAN with the utilization of single-user and multi-user MIMO versus beamforming. In the model, the system model was shown in the figure 1. The result have shown that both single-user MIMO and multi-user MIMO The better data rate and average throughput at 20 ms, but as 45 ms, both single user and multi-user beamforming give like that to data rate and throughput over the case of MIMO. We can see that there is a trade-off between utilization of MIMO and beamforming scheme. Thank you very much.
Good afternoon, everyone. My name is Rano Suwan from KMUTNB. I will be pleased present the main conceptions of this paper. This paper is to concentrate the MIMO bright equalizers that to be optimized by using the software-defined radio in order to compute the signal and data processing. The proposed method is based on an extension of MIMO RFID with the receiver that has been shortly introduced. We introduced software-defined radio for controls the RFID register. So we have also channels equalized without the channel state information. This method has been carried out with the variable step size and constant modulus algorithm. So that's why to compromise the implements of this band channel equalizer. Moreover, we have verified the contributions within the indoor environments, but also we show the performance of proposed. Thank you so much.
This research, the system is designed to formulate the full loop single channel MIMO system, which transmit and receive simultaneously at the same time and on the same frequency band. This figure 2. The channel capacity versus signal to noise ratio for 80% interference reduction when the MIMO system is effect mutual coupling. The proposed technique show a higher channel than the system with self-interference and the system with mutual coupling. Thank you very much.
Good afternoon. I am Ian Zhang from Tokyo Tech, Japan. As you know, millimeter wave wireless system can provide high data rate in short distance transmission scenarios. However, the performance is limited by the characteristics of millimeter wave. In this paper, we propose a multi-user MIMO system with a PAE array, where the directivity of the PAE can be controlled with capacitance of the varactors. And it is possible to design the optimal directivity patterns. However, the control of the directivity may become very complex. Here we also propose a very simple method that the transmitter only select the best combination of the pre-designed patterns to transmit. In the result, the performance is improved very good. Thank you very much.
Good afternoon, everybody. I'm Ponlin Sipoi from HUT. I would like to present you all to the small-scale distributed beamforming for Wi-Fi network. The proposed concept is that the transmitting nodes such as mobile phone or laptop send the same data at the same time to the access point. So it is acting right quality beamforming. From the simulation result we show in the figure 2 show that the proposed concept increase the system bandwidth over the current Wi-Fi system. Thank you very much.
I'm Yuli from Universitas Indonesia. This research is conducted to improve the Indonesian sea surveillance radar that was already developed in year 2010. So this design of antenna is a sub-array antenna for the whole radar antenna. It consists of 4 × 8 elements with dimension 202 millimeters to times 84.5 millimeters. The design is a sub-array aperture coupled patch antenna, so it consists of 2 layers of substrate. The bandwidth achieved is 500 MHz at PSWR smaller than 1.5, with the center frequency is 9.4 GHz. From this sub-array antenna, the antenna gain is achieved is 19.76 dB, but of course this will be arrayed to around 64 elements then. Okay, thank you very much.
You
numerical estimations on shielding effects of continuous for wireless LAN in high-speed drinkers are presented. The aim of this study is to develop an accurate and reliable method of estimating field distributions in drinkers so as to advance radio link design of wireless LAN operating inside cars. We propose to apply large-scale numerical simulations to examine the electromagnetic field created by wireless terminals inside drinkers. Shielding effects due to switch-types connecting doors on propagation characteristics inside drinkers are described. Based on field distribution analysis, the attenuation for the electric field due to the typical connecting door is about 10 dB. Thank you very much.
Good afternoon, my name is Asharia from SUT. We have proposed an idea to tackle the problem of signal loss for wide gigs when employing original beamforming codebook. The problem occurs when users stay in the direction of beam intersection. Therefore, a new codebook-based maximum ratio combining has been proposed. After running some simulation, it can be found that the proposed concept affects lower BER compared with the one employing original beamforming codebook. Thank you.
I'm Naoki Hasegawa from Kyoto University. Our study is about design and fabrication of gallium nitride hyperamplifier for wireless health monitoring system in a spacecraft. The wireless health monitoring system requires the compatibility of LPT with wireless communication. So we separated each frequency and design hyperamplifier for the C-band LPT system. The bottom of slide we show the specs of the gallium nitride hyperamplifier. We obtained 20 watt output power from the amplifier. That's all. Thank you for listening.
Good afternoon, ladies and gentlemen. My name is Paisan Tumat. I'm from Suranandri University, Thailand. Present frequency reconfigurable antenna designed to ultra-wideband wireless communication applications. Figure 1 shows structure antenna. Figure 2 shows return loss reason. Return loss below minus 10 dB. A frequency reconfigurable antenna consists of 5 different paths, and frequency cover ultra-wideband from 3.1 GHz to 10.6 GHz. Can selection spectrum band used as stepping motor controller. A frequency reconfigurable antenna offers many advantages such as easy fabrication, suitability for installation cover spectrum ultra-wideband. Thank you very much.
Good afternoon, everyone. My name is Anissa Kumatan from KMUTNB. I would like to talk about the slot PFAR for HF-RFID sensing tag. Passive sensing tag operating in UHF band for RFID system has been used in the real-time monitoring system in the hospital. From the figure 1, the structure of the fabricated panel inverted F antenna, which is called PFAR, is optimized by a slotted rectangular radiating pan. From the result, a low profile of the slot PFAR for the sensing tag can cover the operating frequency band from 920 to 975 MHz for the UHF-RFID system in Thailand. From the result in the figure 3, the omnidirectional radiation pattern is obtained. Thank you.
Good afternoon, everybody. My name is Ratiya Pongka. I would like to present improvement of communication performance for the HF-RFID system using the printed loop antenna with H structure. This is a printed loop antenna for high frequency radio frequency identification. The antenna structure consists of spiral loop with rectangular structure patch at the middle of the loop. The antenna can be distribute the magnetic field in many directions. And the measure results, the prototype antenna can be efficiently improved. The communication performance in X, Y, and Z direction. Thank you so much.
Good afternoon, everyone. My name is Suvat from SUT. This work is present design of motorcycle generic circuit with very short length, and the circuit is simple to design by using RLC circuit. The Gaussian power is oscillated by using switching circuit and resonance circuit. Shaping circuit based on CRRC, two differentiator and integrator circuit, and use resistor for post-zero isolation. A prototype model is created in PSpice program by using Gaussian power and shaping circuit joined with differential circuit to simulate the motorcycle power. And last, the result is motorcycle power duration approximate 260 picosecond and can be changed to 3.8 GHz bandwidth with teacher by 1 MHz clock. Thank you.
My name is Rajesh Kanana from KMUTNB. This paper presents the study of reflection and transmission coefficient of 2.45 GHz. Microwave signal sending through the sugar solution with different relative permittivity, measured from a pair of coordinate dipole antenna. The result showed that the reflection coefficient was not changed with the difference of relative permittivity. In contrast, the transmission coefficient was decreased with the increasing of the relative permittivity. Thank you.
Good afternoon, I'm Yosita Jinan from KMUTNB. This paper presents design of taper slot antenna with exponentially taper slot antenna or Vivatic antenna. By using the rectangular slot on the edge of taper slot antenna. In this proposed antenna can be achieve the bandwidth from 2.71 to 11.72 GHz. And the proposed antenna, the simulate and measurement term return loss of proposed antenna are shown in the figure 2. Thank you.
Good afternoon, ladies and gentlemen. My name is Chanan Nongla from KMUTNB. Today I would like to present MNG, ENG, and NZI fractal metasurface on slot antenna. The proposed antenna consists of two main parts. The first part is a simple slot antenna, and the second part is a metasurface, which including of the fitness light structure and the cross-setting resonator. In this research, we use the fractal technique to minimize the unit cell. You can see the retrieval result on this picture. We can find the three we have special behavior: epsilon negative, near zero index, and mu negative. Thank you.
Hello, my name is Chief Shanok Yojana. I'm from KMUTNB. This paper presents about an analysis of object burning in soil by using magnetic pencil method. In simulation, the plane wave is transmitted to incident to an object burning in soil. The left-hand portion of transient response scatter from object is used to extract pole by using magnetic pencil method. The pole group obtained from extraction of transient response of object scenario of object is compared with that the object in free space. The object with different shape are also considered. Moreover, we investigate. Thank you.
My name is Lakhana Banawat. We do about performance evaluation of target identification using magic pencil method in different frequency range. Sorry about my PowerPoint is have a problem a little bit. Okay, we have a simulation in the 3 targets. The first is a thin wire, and the second is a plate, and the last one is a sphere. And when we change the frequency range, the profile identification is a change a little bit. And this research is for save cost when you design the antenna. Thank you.
Good afternoon, ladies and gentlemen. My name is Maipon. I give you an overview of gate enhancement for multiband antenna with Hubert pattern slot reflector. You can see the antenna phototype on the left-hand side and the magnitude of S parameter for unit cell with the first iteration on the right-hand side. The antenna consists of a wide slot and a modified rectangular patch with Hubert pattern slot. The multiband antenna can be also achieved by using modulator and factor geometry. The antenna gain can be achieved by using Hubert factor slot frequency selective surface reflector. The first iteration is usually because the simulated results have higher reflectivity and suitable reflection phase that can sanctify for the requirement band. Finally, the antenna and cover the applications of GSM, DCS, PSCS, UMTS, WiMAX, and wireless LAN. And the radiation pattern are still directional pattern. Thank you.
Thank you for attending this young researcher session. So, Dr. Fushima, do you have anything to comment?
Enjoy your presentation.
Okay, just okay. After that, we do have a poster. All the students who presented here, 1 minute per paper. So they have a poster station in next building. It's in 1 floor. So I think you can see. But before you go into see the poster, we would like you to invite all participants, to take a group photos at the TJMW banners in front of this building. So I would like to invite you all because this is a kinen shashin, just a memorial pictures for this kinen. Thank you very much. And we will be back here at